Okay. Okay, guys, so I assume everyone's turned it in because no one's standing up. Am I right? Okay, guys, major complaint about Mr. Foster right now. He gave us the problems, but not the tables. So we have to use a piece of paper to copy down the table part of this problem. Or, I probably shouldn't say this when I'm recording, but, or you can just watch and then print them out because they're on Canvas. Whichever one you find that's going to be more useful to you, whether it's actually writing down, like some people really do have it easy when they're writing stuff down, it sinks in more. It just depends on what you, whether you're someone who learns by writing stuff down or not. But do you guys see how what you have on your sheet is just this written part, but the table's not there? And the U sub n and V sub n. So I'm going to wait a minute or so for anyone who wants to jot down the table to jot down the table. And guys, as you read over this, is this giving you flashbacks to anything you've done? It's kind of similar. Yeah, you guys remember those concentration problems with like hydrochloric acid and all that stuff? This is the same thing, believe it or not. So guys, for those of you who are jotting down the table, these are the n values you're going to want to put. So guys, we are now officially investigating what happens to these sequences as n gets really, really, really big. As n gets really, really, really big, what happens to the sequence? We saw that with Les and Lottie and Holly, right? In the long run, Lottie had no money. Les ended up with 2,070 and Lottie ended up, and Holly ended up with 400, right? Eventually we just say, okay, you got it. All right, oops, sorry, I gotta share this. Okay, so this is where we are. So guys, my advice, don't be looking at your phone during this lesson. This is a very, it's an extension of the prior lesson. So it's not 100% new, at least now you guys know how to do the calculator part. If you weren't here for some reason, this is actually going to be a really good time for you to learn the calculator part because you're going to do it again. Okay, I still see some people writing. You guys, as you're writing, think of how many milliliters are there in 1 liter? You guys, how many milliliters in a liter? Anyone know? 1,000. Yes, 1,000. So there are 1,000 milliliters in a liter. That's going to become important below when we do the problem. So there's 1 liter, or in other words, 1,000 milliliters in this bowl. Okay, guys, ready? Okay, guys, every hour I am taking out 250 milliliters of liquid. What % of the liquid am I removing? You guys, what % of the liquid's coming out every hour? 25%, which means how much of it's left in? 75%. So all of this liquid is clear water except for 16 milliliters, which is colored fluid. Okay, so it's saying we want to complete this table. U sub n is going to be clear liquid. V sub n is going to be colored liquid. So we want to write down recursive definitions for U, N, and Vn. So guys, every hour we're taking out 250 milliliters of what's in the bowl and replacing it with 250 milliliters of clear water. Okay, so that means we're going to every time we take out 250 milliliters, 75% of what was in there is left, but now we're adding back 250 clear water. Make sense? Okay, how about the other? We're taking out 25% of the liquid, which means that 75% of what's left of the colored liquids there. Why doesn't it say plus something? Are we putting any colored stuff back in? No. You guys, what is my starting value? If 16 of the milliliters are colored fluid, what percent is going to be, sorry, 16 is colored. What number of milliliters, if there's 1,000 total, what number of milliliters are going to be clear? 1,000 minus 16, which is 984. Does that make sense, guys? Okay, let's go to the calculator. So guys, just a reminder that your calculator has to be in sequence mode. That means you have to push mode and then make sure it says SEQ, not function. When I put y equals, do you guys see what happens? When I put y equals, it now gives me sequences. Okay, so let's enter in 0.75. So the first equation we wrote. So we're going to do 0.75, and then the u is right above the 7 here. Everyone see the little blue u? I'm going to say second function u, and then I'm going to do parentheses. It doesn't do a subscript. So I'm just going to do parentheses. And now when I push the X button, it now says n because it's in sequence mode. And then I'm going to do plus 250. And I have to tell it what my original, make sure n min says 0 here, because we're starting with the 0th term. So u sub 0 is 984. That's how much we're starting with. Okay, and then for V, which is the colored liquid, I've got 0.75. And then notice the V right above the 8 here. I'm going to do second V n minus 1. And then I'm not going to add anything, right? But I know I start with 16. Okay, guys, this is analogous to our graphing. Remember, whenever we did graphing, we had to look at the window to make sure the window would give us a decent graph, a decent snapshot. Well, we have to do the same thing here, but instead of window, what we want is table set. We want it to start at the 0th term. Right now, mine says it's starting at the 6th term, but I want it to start at the 0 term. Okay, and now up here, see how it says table, guys? We want to generate a table. So let's do second table. And there it is. So what's the question they're asking on the notes, guys? Part C. When, after how many hours will there be less than 1 milliliter of colored fluid? Well, here's the colored fluid. How many hours, guys, is it going to take before I jump below 1 milliliter? 10, right? 10 hours. Now I'm below one milliliter. So rather than write all of that down, we can use ... So I'm going to show you guys. You don't have to memorize that table or anything. I can write up to this. So we saw that at 10 hours is when we jump below 1 milliliter of fluid, colored fluid. You guys, what's going to happen in the long run? Just logically, what's going to happen in the long run? Yeah, we're going to get because we keep replacing with clear liquid, we're eventually going to get so close to 0 on the colored and 1,000 on the clear. We're just going to say, all right already. Does that make sense, guys? Now on the calculator, let's say I wasn't sure. What I could do is I could either use the arrow to scroll down, or I could say, okay, well, let's start at the 50th term. Let's see. So I could go to second table set, and I could tell it I wanted to go down to the 50th term. And then I can say second table. And you guys see this little thing? It's thinking. It has to go through all these lists. Do you guys see what number is that very, very close to? 0. And see how these are all now, okay, all right already. It's all clear liquid. If I just do this, it's going to keep getting, these are going to keep getting closer to 0. These are going to keep saying 1,000. Okay, guys, make sense? All right, shall we spice it up a half a notch? Not a full notch. We're going to make it a little more complicated. Instead of adding in, replacing with clear liquid only, we're now going to replace, we still have our 1,000 milliliters or liter, but now we're going to, every time we take out the 250, we're going to replace it with 234 of clear water and 16 of colored liquid. So we're going to use the same N values that we used in the first example. So let me wait a minute for anyone who wants to write it down. Again, you could just print it out. I do really just want you guys to understand what's going on so that you could do this on the homework. Okay, guys, C is a little different on this one. It says, do the contents of the bowl ever turn into pure colored liquid? What do you think? Taking out 250, putting back in 234 of clear and 16 of colored liquid. What do you guys think? Will I ever get pure colored liquid? No. Right, I'm not adding just colored liquid. I'm adding water back in. Right, so conceptually, I can see I'm not going to be able to get clear colored liquid doing it this way. I mean, full colored liquid doing this way. So this is the interesting question. What happens in the long run? Well, let's set up our equations. So we're starting with the same number, 984 of the clear and 16 of the color. And we're still taking 250 milliliters out, right? We're still taking 250 milliliters out and leaving 75% of what's there for both the colored liquid and the clear liquid. The last time we did all clear water replacement. Now what are we doing, guys? We're adding 234 here, and we're adding 16 here. So this is kind of interesting. Shall we practice again with the calculator? This is good. This is kind of like a reteach because I know APs are going on and people are absent for APs. Okay, let's go back to y equals, guys. And we're going to enter in our two equations. U sub O is 984. And we're going to enter in 0.75 second U n minus 1 plus 234 right? And then now we're gonna go down to 0.75 d n minus 1. Plus 16. And we start with 16. Okay, guys, so our main question here is what happens in the long run? So guys, if I want to know what happens in the long run, watch what I'm going to do. First, I'm going to look at starting at 0. Let's do second table and see what we're at when I start at the 0th term. This is where I'm beginning. So gradually going down, gradually going up. But the question is, what happens in the long run? So guys, what value should I put in? I can pick any big number I want. What term should I start with, guys?
Million.
A million? That'll take forever. It'll be in that little spinny thing forever because we'll have to. How about we do 50? So guys, the reason why if I did a million, I could, but then the little thinking thing would happen for a really long time. Okay, guys, let's do second table. See if that's going to give us enough information. Okay, guys, look. What value is the amount of clear water? First of all, what's 936 plus 64, guys? Yeah, and that's a liter, right? Why are 936 of those milliliters water and 64 color? Think about that a moment in your groups. Why is that the breakdown? Why is the clear water approaching 936 and the colored liquid approaching 64? Okay, guys, anyone have an answer? Why is this 936, guys? You guys, what percent of 1,000 is 936? Guys, what percent of 1,000 is 936? Yeah, and what percent of 250 is 234? Try that out. What's that equal to? Ah, do you guys see? That's also equal to 0.936. Okay, and then how do I figure out where the 64 comes from? Well, what's 64? I'm sorry, 16 over 250. That's equal to 0.064, right? Which is 6.4%. So because I'm adding back in, every time I add something back in, I'm adding in 93.6% of what I'm adding back is clear and 6.4% of it is colored liquid. Does that make sense, guys? That's why eventually the limit we're approaching as it gets bigger and bigger is 936 and 64. Okay, guys, let's say someone ripped the calculator out of my hand and said, no calculator for you. You need to do these limits. Just thinking about this problem and setting up an equation to solve this. Okay, guys, I hate moving back and forth too much, but I'm going to do it anyway. Okay, guys, let's look at, I'm going to go back to the calculator. What do you guys notice on this list about each term and the term before it? So let's compare the 54th term and the 53rd term. What are they? The same. And how about the 53rd and the 52nd? The same. So guys, we are now going to make an assumption. So turn the paper over. We are going to make an assumption. Oh, wait, sorry. You have to write this down or just watch and it's already on the notes printed, posted. Okay, guys, let's make an assumption that any term and the term before it are almost the same. Let's make that assumption. You guys, as limit, this what this means as n gets very, very, very big towards infinity, we're going to say, okay, all right, already, u sub n and u sub n minus 1, we're just going to call them even. And let's just call that some letter x. We can call it anything we want, smiley face, A, B, C, whatever. So here's our equation for the clear liquid, right, guys? This is our starting value, right? So what we're going to do here, actually, no, it's not. That's not our starting value. What we're going to do here is we are going to, instead of writing u sub n and u sub n minus 1, I'm just going to write x. Because we're going to make the assumption that they're the same. You guys, what do you think my answer is going to be? Well, how do I do this? X and 0.75x. What number's in front of that x, guys? 1. And I'm going to subtract 0.75x and I'm going to get 0.25x. You guys, any hypotheses about what I'm going to end up with? Hint, we just saw it on the table. Right? So the calculator was fun and all, but I also, once I make the assumption as n gets really, really close to infinity, really, really big, that the term and the term right before it are the same, I no longer have two unknowns here, right? I'm saying these guys are the same. Okay, I want you to do the same thing with v sub n, guys. Let's just call it y instead. We don't want to call it the same thing. We can call it, I don't know, y. So guys, any hypotheses about what the answer is going to be? Spoiler alert. We already did this with the calculator, okay? Okay, guys, did you get 64? You guys, questions at all? Okay, I want to show you guys something because the homework involves graphing. It's not as bad as it sounds because the calculator will be doing all the graphing for you. Okay, guys, you know how when I'm on y equals, right? I can just push the graph button. Well, I can do that here as well. Before I push the graph button, I usually want to check my window, right, guys? So let's push window and see how it looks different than what I usually see. X-min and X-max look about right. What about this, guys? What is this, do you think? How many terms I want to calculate? Usually we make X-min, X-max the same as N-min and N-max, but can I show you guys something kind of cool? Let's say I want up through 50. I want to do the first turn, 0th turn up to the 50, but I want my screen to say, I don't know, say that's 75. Right? I don't think I need 1,000. You guys, my maximum Y value is 936. So let's say 1,000. Okay, guys, you ready for the magic to happen? You are going to see what these look like graph. right? So here, if you notice, you guys, what value do you think this is? This asymptote right here. What value do you think this is, guys? Yeah, this is y equals 936, right? And what I could do is I could use the trace button, guys, to confirm it. I could say, so guys, if I click the trace button right here, see how that little butterfly thing is on there? Right? Do you guys see when x equals 0, y equals 984? Let's just move ourselves along here. Look what happens, guys. Can everyone see what's happening to y? Eventually, we're just going to say, all right, they're 936 already. Right? I could actually go a little further. We're eventually going to get to 936 already. You guys, what if I want, what's the asymptote down on the bottom? What's this? Y equals 64. So again, I can use the trace feature. I can use the trace feature, and I want to change graphs. I can just go like this. Watch, guys, arrow. And now I'm on this graph. Look, guys, look. See how close it's getting to 64? Okay, that is cool, you have to admit. You guys, all you have to do is push the graph button. And it's going to show you these cool graphs. Okay, guys, the problem on the back is definitely more irritating. And it's also more calculator irritating. Okay, guys, first we need to read this and really understand it. So we've got Uncle Scrooge. So Uncle Scrooge starts with $50,000, guys. But he's a Scrooge, so he wants to take the money out. He doesn't want it to stay in the account. He doesn't want, what was the nephew's name again? He doesn't want Bob Cratchit to get the money. So he's going to take it out, right? So guys, there are rules about how he can remove this money. I cannot take, in order to be able to take money out all at once, I have to have, right? So basically any money, you can't take it all out at once if you have over $1,000. Uncle Scrooge has 50,000, right? So he can't just take 50 grand out at once. Okay, another rule says that no more than 20% or $1,000, whichever is larger, can be removed in any calendar year. So guys, the first year, which would Uncle Scrooge want to do? Remove 20% or 1,000? Which one's bigger? 20%. So first thing we want to find is, where do we want to find out, well, what is, right? I want to find out 20% of what number is 1,000? Where's the break even? 20% of what is 1,000? Because I want to know my threshold for when I'm going to have to start doing 1,000 instead of the 20%. 20% of what is 1,000? Oops, sorry, that doesn't look like is. Okay, guys, how do I set that up mathematically? How do I write that as an equation? 20% is 0.2. You guys, what's of? Of means multiply. What we'll just call x. And 1,000 is equals. So there's our equation. So what does x equal, guys? That equals 5,000. So guys, up till we have only 5,000 left, Scrooge is going to take 20% until he hits 5,000. So his equation is going to be take out 20% until my account is down to 5,000. Okay, this is where Mr. Foster and I had an argument. And the reason is you guys are these separate accounts like Lottie, Holly, and Les. There's just one account and it's having to follow different rules depending on how many years have gone by. So I can't enter it in as different equations in my sequence calculator. So what I'm going to do is this. I'm going to take the first one and I'm going to define it. So the first one, I'm taking out 20%, or Scrooge is taking out 20%. How much is left after he takes out 20%? Okay, so that's for the first, he's going to use this until he hits $5,000 or just under it. So what I would do, this is what I did. I used the calculator for the first bit, and I did U sub n. So U sub 0 is 50,000, right, guys? And I did U sub n equals 0.8 U sub n minus 1. And then I tabled it. First, I made sure that my table is starting at a reasonable value, not 50, we want 0. And then I tabled it and I got this. And I said, okay, I'm going to be using this 20% thing until I get below the 5,000 mark. You guys, when does that happen? How many years does it get below the 5,000? There it is, guys. 11 years, right? At 11 years, it's $4,295. So in the table, I'm going to say, okay, well, 11 years is going to be where 11 years is where that switcheroo happens. So between 0 and 11, I'm going to use my 80%. I mean, sorry, 20%. And then eventually it's going to get below 5,000. Now mine said 4295, so I just used that. Okay, guys, what happens after it gets below 5,000 or 5,000? What am I going to do now? Draw 1,000 every year. So let's figure out, we can do this in our head. How much is left after taking 1,000 for 1 year after the 11 years? Right. When do I have to stop? When can I not withdraw 1,000 anymore, guys? When there's less than 1,000 left, right? So how long is that going to take me? Well, once I get to the 15th year, I don't have 1,000 anymore. So between the 11th and the 15th, and honestly, you could just write 12 because you're not doing fractions of a year. But anytime after the 11th year up through and including the 15th year, Scrooge can take 1,000. But what's going to happen in that last year? What's he just going to do? What's the only amount he has left to take? 295-ish, right? So it's going to take him 16 years to get all that money out. So for his last withdrawal, it will be his 15th year, will be 294.97. Why is it making this sound? Okay, guys, questions. Does it make sense? What's irritating is we can use our calculator for this part, but then it's U11 that's 429,497. So if I write U sub 0, then it kind of gets off kilter. So it's easier to just do minus 1,000, minus 1,000, minus 1,000, minus 1,000. It's kind of irritating, but it's easier. Yes.
So we would always have like two of these would just be the same, like in the range. So it's like 0 to 11 and then 11 to 15.
Yeah, I mean, so basically up to the, including the 11th year, you would use the 20%. And anytime after the 11th year, since these are only occurring once a year, you could write 12 because it's not occurring in the middle of the year. But technically 11 years in one day, you would no longer be, it would no longer be used, better for you to take the 20%. Okay, guys, this is not a very realistic situation because why would Scrooge put his money in an account that doesn't generate interest? What's the point of that? Just stick, you might as well put your money under your pillow. Then you don't have any rules. So it makes a lot more sense. The second part makes a lot more sense. Scrooge puts the same money, same rules, but this time our account is earning 8% interest. Right? And the interest is at the end of the year. So we're going to use the same rules. He still has 20% until he gets below 5,000. So what's that equation going to look like, guys? Now I'm getting 8% interest. Anyone have any surmises, hypotheses? Well, I'm going to take the same thing I had before, but this time I'm going to get 8% on it. And again, I'm starting at 50,000. And I won't reveal the big reveal about what the domain is here. Okay, guys, so all we need to do is insert parentheses into our expression so that it looks like this. So now it's the same thing, only it's times 1.08. So guys, what's your, do you think it's going to take longer to reach that 5,000 threshold? 11 was the magic number last time. What do you guys think? If I'm getting 8% interest, is it going to take me a little longer than 11 years, a little shorter? What do you think? Hypotheses. Yeah, it's going to take a little longer, right? Because I'm getting the 8%. So let's make sure my table is set. I want to start at 0. So let's see, how long is it going to take me to get below the 5,000? Scroll on down. Okay, guys, how long? Now that Scrooge is getting his 8%. Instead of 11 years, it's 16 years because he's getting interest every month. Right, guys? So again, it doesn't super matter if you write down every year. We just want to get the idea that it's the 16th year is when we get below. Oh, what is that? 16th year is when we get below that threshold there. So between 0 and 16, I'm going to use the 20%. After that, guys, what am I going to do? Yeah, but here's the thing. Am I just going to subtract 1,000 from 482,159? No, I have to do that. So this is the part that's irritating. I'm literally going to count on my fingers. 482,159, right, guys? I don't know why it keeps bleeping at me. Okay, so I'm going to go, if I want this home screen, I'm just going to do second quit. So it's 48. Ooh, I don't want that. Second quit. Okay, guys. What? Second quit. Okay. Okay, guys. So what I want to do is I want to do 1.08 times, what was it? 42. Did someone read it to me? 42. No one has it? In front of you? I already forgot. 482159. 482159. 482159 minus 1,000. Okay, guys, this is we're going to count how many years it's going to take to get below 1,000. Okay, guys, does everyone know how to take the answer from the previous problem and insert it into the next operation? It's a fabulous thing on the calculator. I'm going to do 1.08. And then I'm going to say parentheses. And you guys, I just wanted to put the 4127.3172 in. So you guys see how it says ants right above the negative sign? I'm going to do second ants minus, that's the answer before, minus 1,000. Are we there yet? Are we there yet? Nope. 1.08. See why I got mad at Mr. Foster? This is irritating. Second ants minus 1,000. Not there yet. 1.08. I can't hit enter because then will it just enter's just going to give me the same 2567.7. And then and then you can do, but then it's going to take, I can't do that answer minus 1,000 because I have to take 1.08 of that.
If you hit clear and then just hit
If you clear it. Okay, how many times has it taken me? It's taken me 1, 2, 3, 4. I'm almost there. 1.0. It looks like the next one's probably going to be the when we get below 1,000. Let's see, did we do it? Yes. So it took us 1, 2, 3, 4, 5 years. Took us 5 years to get below 1,000. So now we're up to $21, 5 years. So between, we started 482159 and between 16 and 21, we use the minus 1,000, but then we get below 1,000, guys. What's the amount of our last withdrawal? 748.56. So the last one is just taking that minus 748.56. It's going to take us 22 years. I keep saying us. It's going to take Mr. Scrooge 22 years to get his money out with all of those rules. So guys, that was a lot. Okay, I'm going to show you guys the homework. Yep. So guys, do you see how there's a part 3 and 4 down at the bottom? That's part of the homework. In addition to the sheet that's posted on Canvas. So again, luckily, this is all accessible on Canvas, these notes. Which is good. Okay. Let me.